Today I just wanted to post this video that will hopefully help you on IXL Math X.5 down to X.8. And this is where you're finding the missing number that will give you a certain mode, mean, median, or range. So at this point you should be getting very familiar with what it means to find the mode, mean, median, and range. But now we're going to look at kind of a little higher level question with that. I have my thinking paper over here that I'm going to be going back to as we need it. I should be able to slingshot over to that. And so we are going to look first at X.5. And this is finding the missing number that will create whatever mode they tell us. So we know mode is the number that occurs the most often. So they've given us some data here. It is not in order least to greatest as it should be. So with only 4 numbers, we could probably mentally think 1, 6, blank, 12. And they tell us that they want the mode to be 6. So the number that occurs the most needs to be 6. Well, if it was 12, there would be 2 12s, so that wouldn't be the mode. And if it was 6, that would give us 2 6s in our data, so that is our correct answer. Same thing here. Marco has the following data. This data has also not yet been put in order least to greatest, but we could mentally think 2, 3, 4, 5. And then again, if we want the number, if we want the mode to be 5, then we need to choose the number that will make there be more 5s than anything else. So we will choose 5. The mode is pretty simple for a missing number, so I'm only going to do one more example here of that, and then we'll move on to something a little bit more challenging. So here, if the mode is 44, which number could Q be? If the mode is 44, then you would need more than one 44 in this data. And we could go on from there. So now we are going to go back and look at what we would do if we wanted to find the missing number for mean, X.6 on IXL. Now, mean is our average, so mean means that we're going to have to add up all of the data and divide by however many numbers there are. So, if we want the mean to be 17, then they've given you 2 options to plug in for C. So basically, we're going to have to calculate the mean twice. Once using this number 20 and see if it gives us a mean of 17, and then we're going to have to plug in the number 26 and see if that gives us the correct mean. So I'm just going to write down my data here, and I know you won't be able to see it just yet, but I'm going to write down my data, and I have not put this in order yet, but I'm just giving myself a blank where I can plug in different options for C. And I know my options are either going to be 20 or 26 based on this question. So I'm going to jump over here to my, and they want the mean to be 17. Keep that in mind. So I'm going to put that on here. And we are going to add all up. And we're going to divide by how many numbers? 1, 2, 3, 4, 5. Don't forget that that variable, that letter C, does count as a number, because we're going to be plugging in some choices there. So there's 6 pieces of data, which means I will be dividing by 6 for my mean. So I'm going to kind of jump over here to my thinking paper real fast. You can see that I've written down my data. This is my blank, where I'm going to either use 20 or 26 when I plug it into my calculator. So I'm basically going to find the mean. I'm going to add these all up using 26 and see if I get 17. If that doesn't work, then I'll scratch it out and I'll try 20. So I'm going to flip to my calculator here on my phone, and I'm going to add them all up. Now, I did not put these in order least to greatest. I know that. I said it's just a good habit to get into, but realistically with mean, it's not going to change the mean. So what I did there is I added all those up with 26. Now I'm going to divide by 6 numbers, because that's how many numbers there are in my data. And I got 18. So see, 26 did not work. So I either made a mistake with my calculating, or 20 is going to be the answer. So let me just plug it in with 20. I'm going to add up all my data very carefully and divide by 6. And I got 17. So that tells me that my missing number is going to be 20. So mean, as you can tell, is going to take a little bit more work to get through. But yeah, that's why I'm only requiring a SMART score of 50 on these. However, feel free to go higher than that. So here's Kendra's data, 10, blank, 10, 10, 9. So I'm going to list out my data here. And I'm just going to put a blank where the M is. And then I'm going to write my two options. It could either be 26 or 11. And they want the mean to be 10. And so I am going to add them all up and divide by 1, 2, 3, 4, 5 numbers. So add, divide by 5. So I'm going to slingshot back over to my thinking paper, set up my data. I put my two choices in for what will give me a mean of 10. So I can just simply add that up and divide. So I'm going to kind of predict here that with the mean being 10, and all these numbers being very close to 10, I'm going to go ahead and predict that it's the 11 that's closest to all my other data. Oops. So I'm adding them all up using the 11, and then I got 50, so when I divide by 5, that'll give me my 10. So I chose the correct one the first time. I could always check it by plugging that one in, but for the purposes of this video, I'm going to go ahead and click on the correct answer. So that is how you would find the missing number for mean. I think it is important that you probably write something down for this one so that you can kind of track your progress, especially for like this one where the first number I plugged in didn't work. It also is helpful because you can write in what you're supposed to be dividing by, because remember, for mean, you have to add all the numbers up, but what you divide by will be different depending on how many numbers are in your data set. So this data set had 5, so I divided by 5. This data set had 6 numbers, so I divided by 6. And so your thinking paper is going to probably be helpful on that activity. Alright, so now we are going to go jump over and do a couple of examples for finding the missing number for median. Now median, this is going to be x dot 7. Median is the middle. Now median is only the middle though if your data is in order least to greatest. So on my thinking paper, I'm just going to draw myself a little line here, and I'm going to go ahead and set myself up that I am calculating the median, which means that it is very, very, very important that my data be in order least to greatest, because the median is the middle when my data is lined up least to greatest. So I'm just giving myself that little note on my thinking paper, and I can tell that this data they've given me is not in order. So as I write it, I'm going to make sure I'm putting it in least to greatest order. So I have a 10, 11, 15, 15, and then my blank, I can't really plug my blank in anywhere just yet because 14 or 6 would be in two different places. What I can make note of is that my median needs to be 11. So I'm going to put that on my paper to know that that is the goal I am looking for. And my choices are 14 or 6. So I've written kind of all this down. I'll show you what it looks like. These were my options over here. So I'm going to plug these in and see what will give me a median of 11. So I did write my data in order least to greatest. The 6 would go over here. So I'm just going to plug that in and see if it would give me the median of 11. So I'm going to work my way to the middle. And that indeed does give me a median of 11. So you can see, just in case that didn't work, if I had done 14, I would have put 14 here. Oops, no, I wouldn't have. Sorry. I would have put 14 here, so it's in order least to greatest. If I had done 14, then that would have actually been my median, which proves that's not right. Okay? So my median for that one should have been 6. And now we'll try another one. Again, median's the middle. It's got to be lined up least to greatest. So I'm going to write my data out first. I'm going to ignore that Q, that missing number. I'm just going to order 12, 14, 16, 20. And I'm going to let myself have a little note here that they want the median to be 14. That is what I'm trying to figure out. And then my choices here are 19 or 9. And so I've got that all written on my thinking paper here. This is what they want it to be. These are my choices. So I'm just going to take a little prediction here and plug which one in I think would work. So I'm going to take the 19 and I'm just going to plug it in right here. And then I'm going to find my median and see if it works out. So 12 is gone, 20, 14, 19. So see, this leaves 16 as my median. So 19 actually did not work. It did not give me the median of 14 that I wanted. So now I'm going to scratch out the 19 because it didn't work. And I'm going to plug in the 9 up front. Alright, so now I'm going to take, probably helpful to have a different color, and slash out 9 and 20, 12 and 16. So now I can see that my median is indeed 14. So then that means that 9 should be the missing number. Alright, so that one takes a little bit more work because you got to make sure your numbers are lined up least to greatest, and then you're just kind of trial and error, plugging one in and seeing if it works. Alright, so last but not least, we're going to go look at finding the missing number for range. And range is, of course, going to be how much our data spreads or varies. And so we're going to, of course, want the data in order least to greatest, or really just most importantly, if we're doing range, we really need the least number and the greatest number so that we can subtract. So on my thinking paper, I am going to let myself know here that I'm doing range. So I'm going to have the greatest minus the least. And so you can see I've just got that written out here. And I'm just going to try out the greatest and the least and see if it gives me the range that the IXL question has asked for. So right now my greatest number, remember these are not in order, so I've got to look. If I want my range to be 14, now my greatest number is 20. And then my smallest number would be 1 if I included that in the blank. So 20 minus 1 would be 19, so that's not going to work. For the next one, if I did 20, the greatest number, minus, if this 20 was in my data, it wouldn't actually be used in my range. 6 would be the smallest number. So 20 minus 6 does give me 14. Alright, I kind of talked my way through that first example, so I'm going to go ahead and write this one out for you to see a little better. So I'm going to go ahead and order my data, least to greatest, on my thinking paper first. So I have my data listed out here, 17, and I wrote them in order least to greatest, 17, 19, 19, and 20. They want my range to be 3, but I have to either add in a 10 or a 19. So if I were to take this 10 answer choice, it would end up being my smallest number. And if I did 20 minus 10 to find the range, that would not be 3. So that will not work. So I'm going to scratch that out. If I take this 19 answer choice and I plug that in, that would go here, so that would actually not affect my range because now I'm doing 20 minus 17, which is 3. And so 19 will give me the answer that I want for range. Next one, only 4 numbers here, and then we're going to have to add in one of these, but we want our range to be 8. So whenever we subtract the greatest minus the least, we want it to give us 8. And so I am going to write my data out really quickly. So I have written my data in order, 35, 39, 43. And then I'm either going to add in this 24 and this 43 with the hope of getting a range of 8. So if I add in this 43, it would go here. And I would be doing 43 minus 35, which will give me 8. So this looks good so far. I'm going to get rid of that for just a second and just to double check and show you how this works. If I took the 24, it would end up being my least. And then I would be doing 43 minus 24, which would give me something other than 8. So that's why that is my answer. So I can slingshot over and choose 43.